Okay, in this data set we have data about refraction. So we have angles of incidence and refraction measured and plotted. Right, and we're going to basically look at Snell's law in this data. Right, so what does the physical quantity of a gradient represents? Well, we start with Snell's law. Right, Snell's law relates sine I and sine R, and our graph is sine I and sine R. So write down Snell's law. Sine R over sine I in this case is the refractive index going from plastic to air. So we can rewrite that sine R equals n times sine I. So then that n term is the gradient of our sine R versus sine I graph. So our slope is the refractive index. If we want to calculate that, we need to look at the graph and get the slope. So we go along here, and it's a little hard on my screen, but I've tried to draw a line of best fit and measure its slope. Alright, drawing a line of best fit. It's a little high, but we'll just run with it because sometimes we measure rise of a run to get our gradient. I take the origin as 1 point and my second point, choose the intercept on that far edge of the box there, because as far apart as possible it's going to be the best. 0.55 minus 0 over 0.8, so that's my rise divided by my run, get a gradient of 0.69, which is I'll just use those calculations in the box. Slope is 0.69, and that slope is equal to the refractive index going from plastic to air, which is not where we're after index from going from air to plastic, right? Which is 1 over the index from going from plastic to air. 1 over 0.69 is 1.45. So that's our refractive index for plastic. This room. Using error analysis, we've got our accepted value, and we've got our measured value. We take the difference between those, take the absolute value, 0.06. Right, that's percentage as well. Right, as a percentage, it's about 4%. So I can say this is reasonably small. Our results are relatively accurate. Right, so I want to think about UV light. We change our refractive index to 1.53, right? Using a different frequency from the same plastic, it's the refractive index. The refractive index is slightly higher, right? So our slope, which is 1 over that, will be slightly lower. This graph we get will be a little bit shallower, but almost imperceptibly shallower compared to what we had in our original data set.